Okay, so a couple of people have messaged and asked in a video, what if you get a function that has a maximum and a minimum point in it? Yep, you probably will get one of them. And it's probably one of my favorite questions to do because it comes up so much and I'm so used to doing it. But yeah, I'm going to show you. So this is going to include using the first derivative and the second derivative. So I want to find a maximum minimum point, and I've said in previous videos, whenever you see the term maximum or minimum, you must differentiate and set equal to 0 and find that x value. So that's what we're going to do first. We're going to differentiate. So differentiating here, simple power rule stuff here. So it's going to be 6x squared plus a 10x and a minus 4. Okay, I'm trying to keep this a little short, so the next step here I have in previous videos is when you differentiate, now you're going to set equal to 0. So equal to 0. So this is a quadratic equation. You see these all the time. You should be able to factorize it. Because it's an equation, you can actually divide it down by a constant if you want to make it easier. So I'm going to divide every term by 2. That's going to give me 3x squared plus 5x and then a minus 2 equals to 0. Now I have to factorize it to find solutions. We've been doing this for, if you're sixth year, for 6 years probably nearly now. So 3x and an x equal to 0. And I'm going to put a plus 2 here, and it looks like a minus 1 here. Okay, if you can't get these solutions, use them, by all means use the minus b formula, but I'm just going quickly here. So this is going to be 3x equal to 1, or x equals 2 and 1/3, and this gives us an x equal to minus 2. Okay, so these are our 2 points where they're either maximum or minimum. So one of these is clearly max, one of these is clearly min. I had said previously before, there's like a cheat way of doing this where you can put the third or the minus 2 in here and get the y number that goes with it. And obviously the y number that's higher up the graph, so if you get a big positive y number and a low y number, that big positive y number must be the maximum and the low number must be the minimum. So it's like a cheater way of doing it. But sometimes they'll say in the exam, use the second derivative test to show that. So what the hell did I mean by that? Well, these are our 2 x values for our max or min. We don't need the y values yet for the coordinates. So what we'll do is we'll use the second derivative test. So without explaining it too much, I'm just going to do it and explain it as I do it. So a second derivative, I differentiate again this derivative function here. So that's going to go to 12x, and that's just going to go to a plus 10, and of course the constant goes. So I have my second derivative here. And what is the second derivative test? Well, in the second derivative test, we actually take these numbers and we put them into the second derivative and we see what we get. So let's take 1/3 first. So let's put 1/3 into the second derivative. That gives us 12 times 1/3 plus 10.